Hi, welcome to our AP Stats notes for 7.5. We are looking at 7.5, the normal approximation to our binomial probability density function. So just as a reminder, what does it mean to be binomial? It means that there are exactly two outcomes, either success or failure. The outcomes are disjoint, the probability of success is fixed for all trials, and the number of trials is also fixed. So for example, if we go to all college students taking Criminal Justice 110, Section 11 at Illinois State University, and we ask them if they live in a dorm. Our outcomes, we have two of them, either yes, I live in a dorm, or no, I don't live in a dorm. You cannot have non-disjoint outcomes. They must be disjoint because either you live in a dorm or you don't live in a dorm. Those are the only two outcomes. The probability of success is fixed. It's the same as the percent of students that live in a dorm. And the number of trials is fixed. It's how many students are in that class. So we talked, I mentioned it once, we never really talked about this, but it was mentioned briefly that for a fixed binomial probability event to be approximately normal, NP times 1 minus P must be greater than or equal to 10. So what I would do is I would take N times P times the value of 1 minus P, and I would check, is that greater than or equal to 10? And if it is not greater than or equal to 10, then what I can claim there is that that first example is not approximately normally distributed. So I do not have an approximately normal distribution on number 1 because NP times 1 minus P is not greater than or equal to 10. So this is not normally distributed or approximately normally distributed. All right, please pause the video, check 2, 3, and 4, see if those are normally distributed binomial probability events, and then unpause to check your work. All right, so 2, that would be normally or approximately normally distributed, so we would say this is approximately normal. For 3, it's close, but it is not going to be normally distributed. It's close, but not quite. And then for 4, that is approximately normal because it's greater than 10. All right, on the next page, I want to determine what n value I need in order to have an approximately normal distribution. This is very important for a known probability if I'm trying to do a simple random sample. So in the spring, we will do a project in which you will have to find some number of data points, and how many data points I need, n, how many trials I need, is tightly related to how many, what percent, what probability each trial will have. So what I would want to do here is I would want to take n times 0.3 times 0.7 is greater than or equal to 10, or I would say 0.21 is greater than or equal to 10. .21n is greater than or equal to 10. So if I divide by 0.21, I'm going to get n equals 47.62. I'm going to round up to 48 trials. We're always going to round up. right, please take a look at 6, 7, and 8, and we'll solve for n. Even here, we got 42.9 for n, so I get 43 trials. And our last one, 10 divided by 0.2016, 49.6. So we gotta have 50 trials. And it has to be rounded up because it's greater than or equal to 10. So you'd have to round up to make sure that product is greater than 10. All right, now for this one, let's work on a challenge question. If I gave you n is 200, what's the minimum value for p that will give our binomial probability function an approximately normal distribution? I'm going to ask you to solve for, if you get this function, you should get this written as a trinomial. So write this as a trinomial, distribute, simplify, get everything on the left side. What I'd like you to try to do here, if you ignore the greater than sign and just work as an equation, get everything to the left side, graph it, and I want to know what is our value for p, what are our critical values, our zeros or our roots for p. Use your graphing calculator, check it out, check the completed notes. And our last part, normal CDF versus binomial CDF. So according to the Red Cross, 7% of people in the US have O negative blood. What's the probability that in a simple random sample of 500 people in the US, fewer than 30 have type O negative blood? So first of all, is it binomial? Do we have a fixed n? N is 500. Yes. Do we have a fixed p? Yes. P is 0.07, 7%. Do we have two outcomes? Type O, not type O. And do we have disjoint outcomes? Yes, you cannot be both type O and not type O. So let's check. Approximately normal. If I take 500 times 0.07 times 0.93, 500 times 0.07 times 0.93, I get 32.55. That is in fact greater than or equal to 10. Check that box. So I'm going to use binomial CDF NP and our x value cutoff, which would be 500.07, and our x value cutoff was 30. And this is going to tell me what's the probability that less than or equal to 30 have type O blood. Now, if I wanted to use the normal CDF, then I would need a low bound, a high bound, a mu, and a sigma. Well, I know my low bound would be 0. I know my high bound is 30. But what I don't know is my mu or my sigma. So what we have to do is we have to calculate mu, which is NP, and sigma, or I'm sorry, mu sub x. I should be more careful with that. And sigma is going to be the square root of our NP times 1 minus P. And then I'll check my values and I'll do the homework.